Good morning, y'all. So continuing into our radicals unit, I wanted to today talk about adding and subtracting with radicals. So we're going to start moving into operations, adding, subtracting, multiplying, and dividing. But today I just wanted to simply work on the adding and subtracting piece. So there's only a few steps when it comes to adding and subtracting of radicals. The first one being that you have to simplify. You have to simplify all the radicals to their lowest form. So simplify all radicals to lowest form. So an example of what that means is that, like, if I have the square root of 20, we've done a bunch of this. That would simplify to 2 square root of 5. So that's the lowest form there. And then step number 2 is that you want to combine all the like terms. And what we mean by like terms when we're referring to radicals is that they must have the same radicand. So must have the same, and I'm going to switch this color to green because that's what we've been using, radicand, or that's the index and insides. So it must have the same radicand, and you add or subtract coefficients. And I'm going to do that in blue. And the coefficients, that's the outsides. All right, so what does that look like? Because it's easy enough to tell you the steps of how to solve, but sometimes this can be abstract and we need to actually see problems to figure that out. So here's my first example, example number 1. Let's say I have the square root, or 3 square root of 2 plus 5 square root of 7 minus 4 square root of 2 plus 3 square root of 7. Now, the first thing that we want to do is make sure that all of these radicals are in their simplest form, and currently they are. Square root of 2 and square root of 7 for any of these wouldn't simplify down anymore. Now, combining all the like terms, they have to have the same radicand. So, as I look at this, this one has a square root of 2. This one here also has a square root of 2, so that means that those are like terms. Vice versa, we have here, we have square root of 7. Oops, I wanted that to be 2 different lines. And then here we also have a square root of 7. So those are also like, no, don't combine that. Those are also like terms as well. So I'm going to add together the ones that have the same radical. Here we have a square root of 2. Here we have a square root of 2. So I'm going to add together the negative 4 and the 3. And that gives me negative 1 square root of 2. And then for the square roots of 7, square root of 7, I've got a 3 square root of 7 and a 5 square root of 7. That would give me plus 8 square root of 7. And that would be my answer. So simplifying this expression would come down to negative 1 square root of 2 plus 8 square root of 7. Let's look at another example. So in example 2 here, I'm going to give us some problems where we actually have to simplify the square roots. So we have 3 square root of 8 plus square root of 12 minus square root of 18. So first step is you have to simplify the radicals. Each one of these can be simplified. 8 that is 4 and 2, and then 4 is 2 and 2. For 12, that's 4 and 3, and then 4 is 2 and 2 again. 18 is 9 and 2, which is 3 and 3. So, similar to what we were doing before, you look for the pair that multiplies with your outside number. So that gives me 6 here with the square root of 2, because I had that 2 remainder. For this one, I have a pair of 2's with a leftover 3. So that's 2 square root of 3. And then finally, for the last one, I've got a pair of 3's left over 2. So that's 3 square root of 2. So here's all of our expressions simplified to their lowest form. Simplifies to 6 square root of 2 plus 2 square root of 3 minus 3 square root of 2. Now, let's combine our like terms based on our radicals. I've got a 6 square root of 2 here, and I've got a negative 3 square root of 2. So when I add those two together, I'm going to get a positive 3 square root of 2. And then this 2 square root of 3, there was nothing to combine with, so that's going to remain 2 square root of 3. So that is my answer for this problem here. Another example, this one I'm going to throw in a different index, so square root of 32 plus the cube root of 16. Remember the cube roots, when you have a different index, that's the number of numbers that you need for that. That's bad. That's the number of grouping that you need for that number to come out. So for 32, that'd be 16 and 2. 16 is 8 and 2. 8 is 4 and 2. And then 4 is 2 and 2. So I've got 2's here, 2's here, this leftover 2. So that simplifies to 4 square root of 2. And then for cube root of 16, 2 and 8, 4 and 2, 2 and 2. Remember, because it's a cube root, I need a group of 3 here. So that's going to be a 2 cube root of 2. Now, here is why these two can't simplify together. This is a square root of 2, and this one is a cube root of 2, so those are not the same radical, right? It has to have the same index and the same insides. They have the same insides, but their indexes are different, right? This one is a cube root rather than it being a square root. So actually, my answer is this. It's 4 square root of 2 plus 2 cube root of 2. That would be my answer for this problem. Now let's look at one more example. This one I'm going to have some more challenging simplifying problem. Let's do 2 square root of 12 minus 6 square root 75 plus 36. Square root 36, excuse me. So let's simplify these here. 12, that's going to be 4 and 3, which is 2 and 2. So that's my pair. That's my leftover. And that 2 gets multiplied with this 2 on the outside as well. So this becomes 4 square root of 3. 475, that's 25 and 3. 25 being 5 and 5, so there's my pair, that's my leftover. That 5 is going to multiply with this negative 6 in front as well, so that gives me a negative 30 square root of 3. And then the square root of 36, that's 6 and 6. The square root of 36 is 6, so plus 6 here at the end. Now, all of these are simplified down. The last step to do is just to combine the radicals that are the same and make sure that they have the same index as well. So I have a 4 square root of 3 minus 30 square root of 3. That gives me negative 26 square root 3. And then this guy over here, this 6, there's nothing for him to combine with, so that's going to remain plus 6 at the end. So final answer, negative 26 root 3 plus 6. So those are a few examples of adding and subtracting of radicals. We will go over this more the next time I see you in class, but make sure you copy down these notes into your notebook and you submit a picture as your assignment. Thanks, and